Hello everyone, welcome back to Educquiz. We are on the exercise 5 on partial fractions. The exercise goes by 5x minus x squared all on x into x minus 1 into 2x plus 1. You can see that this is quite simpler than all of the other ones that we have been doing. So let's write the question. We have 5x minus x squared into 2x plus 1. So, how do we solve this? We first check the first requirement. The first requirement says the numerator's degree must be less than the denominator's degree. What is the numerator's degree here? The numerator's degree, let's remember, it means the highest power of x. The highest power of x here is x. It's not 3 because down here I used to add the power here 1, 2, 3 and so that the degree is 3. Well, down here I used to add because it is multiplication. So I can add this to this to this because when they will multiply, they will actually add and give the highest degree of 3. But here is addition or subtraction. Here is subtraction. This can never mix. It will always remain like this. So the highest power of x is 2 here. X squared multiply this, I have x cubed somewhere. So again, x cubed somewhere. So that is why the degree of the denominator is 3 and that of the numerator is 2. So when we know that, we see that the first requirement is fulfilled. The numerator's degree is less than the denominator's degree. Then we can go to the next requirement, which is the denominator must be factorized. And in this case, it is factorized. You can see it's factorized. Yeah, so when this is factorized, then we can go to the next step, which is putting the equation in partial fraction form. In partial fraction form, since we have a fraction with linear factors at the denominator, that was the first type. So it is just going to be a on the first factor is just x. You put just x, you don't put x into x minus 1. The first factor is just x even factor. A on x plus b on x minus 1 here plus c on 2x plus 1. You can actually solve with cover-up method. But I'm not going to solve the cover-up method. If you solve the cover-up method, you see the answers direct. So try and solve with the cover-up method and compare answers with what I'm going to have here. So what I'll do here naturally, I'll find the LCM. The LCM here is just going to be the product of the 3. Product of the 3 is going to be x into x minus 1 into 2x plus 1. So for the first value is going to be a into, I do this denominator divided by x. And under the denominator divided by x, I will see that this x will cancel this x. It will be a into all of this rest. I'll have a into x minus 1, so x plus 1. Oh, I see that this is going to be long. Plus b into x minus 1 will disappear from here. I'll have x times 2x plus 1. X 2x plus 1. Plus c into, I see that 2x plus 1 will disappear from here. I'll have x and x minus 1. Yeah, when I have it like that, I can recopy the left side as now nothing has changed here. So I'm going to have 5x minus x squared all on x into x minus 1 into 2x plus 1. Just like that. So what next am I going to do? I'm going to do my cross multiplication. When I cross multiply, I'll see that this will come here and this will come here. When they will come, because that this which will be there will cancel with this which will be here because they're actually the same things and I'm multiplying everything here. So if you have 1 is equal to 1 plus 1. If you have 2 minus 1 is equal to 1 plus 1, all over 2, all over 2. Let's assume that 2 minus 1 is this, and 1 plus 1 is this, all of this. All over 2 is this, all over 2 is this. You can see that this and this is the same thing, because that's why this and this is also the same thing. If I cross multiply, all will happen is that you have this 2 minus 1 into 2. All of them multiply 2. I'll put a bracket because all of it is multiplying 2. If I don't put this bracket, it means 2 is multiplying just this one. So I put the bracket to show that all of it is multiplying 2. It's equal to 2 into 1 plus 1. Yeah. Let me just put it behind so it should be more clear. Yeah. So I've seen that this 2 has come here, this 2 has come here. They can just cancel. Because if I divide, or if you don't want to just cancel, this is what I will do. I'll divide all through by 2, divide all through by 2. When I divide all through by 2, this 2 will cancel this 2, this 2 will cancel this 2. So you'll be left with 2 minus 1 is equal to 1 plus 1. Let me just say 3 minus 1. It looks bizarre when it is 2 minus 1. 3 minus 1 is equal to 1 plus 1. You can see here that this will give 2, this will give 2. This 2 here has cancelled under. So that is the same thing that happens here. This will multiply this will multiply this, and this one and this one will cancel, just like these denominators cancel. So that is what we have done. That was just small something for people to understand. So what next do I do? I'll be left just with the numerators. If I'm left with the numerators, I'll have 5x minus x squared is equal to a into x minus 1 into 2x plus 1 plus b into x into 2x plus 1 plus c into x into x minus 1. So from here, you can either expand and compare the coefficients, or you can substitute values. You can let an x to be anything depending on the equation that I have here. So depending on this, what value of x can I put here to make all of this to be 0? We can all see with our eyes that it is 1. If I put 1, 1 minus 1 makes 0. 0 multiplied by this will give 0. 0 multiplied by this will give 0. So 0 multiplied by anything is 0. So if I put 1 here, I'll have 0 right all through here. So I have my first value as 1. If you don't know how to find the value, just equate this to 0. X minus 1, you equate it to 0 like this. And you find x is equal to 1. You replace your 1. So since this one is equal to 0 already, you go to the next one. B times x times this. What can I do so that this thing turns all to 0? I'm saying I have x here. I have an x here. It means that if I replace x by 0, I'm going to have all of this going to 0. So my second value is 0. Let's come here now. What value of x? I've already used x as 0. What value of x can I make to make this thing to be 0? When I use 1, I'll have it at 0, but I've used 1 already. I used 0 already. So I'm going to use... You could take this one. We could take this one and look for a value of x that when we multiply, when we put here, we're going to have 0. We're going to have 2x plus 1 equals to 0, x equals minus half. But if you use minus half, you are going to have so many, here we are going to have, for instance, 1/4. So it's not advised to use fractions, because you might do errors with fractions. You have half minus 1, this, okay, this will go to 0, this will go to 0 actually, half minus 1. Well, if you want to put minus half, it is still correct, you'll have the answer. But I personally don't really like to work with fractions, so I will not be tempted to put this. So when I have 1 and 0. The next thing I'll be tempted to use is negative 1. But let's use the negative half. Let's just use the negative half like that. If you use negative half, you are still going to have the correct answer. So letting x be 1. When I let x to be 1, I replace my 1 here and here. I'll have 5 times 1 is 5. 5 minus 1 square is 1. It's 4. 5 minus 1 is equal to 4. You can replace your 4 here directly. Or I can still put 4. Well, I'll leave it like that. 5 minus 1 is equal to 4. When I put 1 here, all of this goes to 0. Because 1 minus 1 is 0. So this will be 0, this will be 0. Because this is 0. When you multiply by 0, you have 0. So all of this is 0. I switch to here. When I put my x as 1, this is b1. b into 1. 2x plus 1 is 2 plus 1, 3. Plus c into x is 1 into 1 minus 1 is 0. So all of this actually will go into 0. So all of it will go. So 5 minus 1 is 4. Is equal to 3b. Which implies b is equals to 4 and 3. Yeah, that's it when I let 1. So for the second one, I'll let x to be when I let x to be equal to 0, I replace 0 here. I have 0 minus 0. So here I have a into 0 minus 1 is minus a times 2 times 0 plus 1. I can't write everything because a plus. When I put 0 here, all of this will go to 0. b times 0 times 2x plus 1 is 0. So I'll just put the 0 there, plus 0, or I'll just leave it like that. Even here, when I put 0, everything goes because of the same reason. Which implies a is equal to 0. A is equal to 0 indeed, because you consider it from here you can factorize x. When you factorize x here, x will cancel with this x. From here, if you factorize x, what are you going to have? You're going to have x into 5 minus x, all on x into x minus 1 into 2x plus 1. So this is going to cancel with this. They're going to be left just with 5 minus x over x minus 1 into 2x plus 1. So you just have to find b and c in this case, because a does not exist, a is 0. If you solve it with it, it is still correct. You see at a to be 0. So in this case, we have had our a to be 0. So letting x to be minus half. Letting x to be minus half. When we put minus half here, what do we have? Half minus 5 on 2 minus, what is minus half squared, 1/4. The minus will take care of the square will take care of the minus. So you have minus half squared, which will be 1 on 4. If this minus remains, so it is minus 1 on 4. So it is equal to, when I put minus half here, I'm saying that minus half will make this to be 0, just like we calculated before. Minus half will make this thing to be 0. So all of this is going to be 0. Same here, this minus half will make this to be 0. So all of this is going to be 0. So I come here and I put my minus half. Minus half A. So minus half here, I'll have C into minus half into minus half minus 1. So it's equal to, I'll have minus 5 on 2. Okay, if I multiply this side up and down by 2, I'll have minus 10 on 4 minus 1 on 4. So when I have the same denominator, I can do my LCM. I'll have 4. 4 divided by 4, 1. 1 times minus 10, minus 10. Minus 4 divided by 4, 1. 1 times 4. 1 times 1, I mean 1. I'll have minus 11 on 4. That will be equal to C into minus half into minus half minus 1 minus K on 2. So I'll have C. I'll bring this side here and this side here. I'm going to have 3 on 4. C is equal to minus 11 on 4, which implies 3C is minus 11, which implies C is minus 11 on 3. So we've had A, B, and C. So our final answer, we are going to just plug it. So A is 0, this is B 0. So B is 4 on 3 x 1. C is minus 11 on 3 2x plus 1. And that is it. So you can see this one was not that much difficult than the other ones. So thank you for watching the exercises all through to exercise 5. Hopefully you've watched all through to exercise 5, and keep learning with us on Educquiz.